Hello students, welcome to my YouTube channel. I am Vishwanath. Today I am going to discuss about terrestrial magnetism or earth magnetism. This is a bar magnet. It has two poles. One is north pole and another is south pole. That is, one is N pole and another is S pole. Now I suspend this bar magnet by a vertical thread. The N pole always directs along a certain direction. That's why the N pole denotes the magnetic north pole of the earth and S pole denotes the magnetic south pole of the earth. Okay, and you can see that the axis of the bar magnet makes some angle with the horizontal line. This line is known as angle of inclination or angle of dip. Okay, now I am going to discuss some details. Okay, let x prime OX or XO X prime is a horizontal line. NS is the axis of the bar magnet. Okay, now the angle between the horizontal line and the axis of the bar magnet is known as angle of dip or angle of inclination. You know that in the northern hemisphere, the north pole of the bar magnet inclined towards the earth. Okay, in the southern hemisphere, the south pole of the bar magnet inclines towards the earth. Okay, that's why in north pole it is denoted by angle of dip is denoted by theta n. Okay, theta n in the northern hemisphere, and in the southern hemisphere it is denoted by theta s. You know that along the axis of the bar magnet, the intensity of earth magnetic field at that point acts. Okay, let V be the intensity of earth magnetic field at this point. Okay, or in this place. They are now BV and BH are the vertical. BV is the vertical and BH is the horizontal Earth's magnetic field, or the BV and BH are the vertical and the horizontal component of B. Okay, therefore we can resolve B into two components, mutually perpendicular components, that is BV is equal to B sin theta and BH is equal to B cos theta. Okay, now dividing, we have tan theta is equal to BV by BH. Clear? This is the angle of dip or angle of inclination. Okay, by this we can say that the place either is in northern hemisphere or is in southern hemisphere. Okay, on the equator the angle of dip will be 0. That is, the magnetic axis is parallel to the horizontal line. You know that position of magnetic north pole, not exactly at the geographic north pole. It is somewhere at the place, some place at the in Canada, and the magnetic south pole of the magnet of the earth does not placed exactly at the south pole of the earth. It placed at the some place in Australia. That's why we can say that the geographic north pole and south pole and earth magnetic north pole and south pole are not same. It is slightly different. Okay. Now let NG and SG denote the geographic North Pole and geographic South Pole, and NM and SM denote the magnetic Earth magnetic North Pole and Earth magnetic South Pole. Now the angle between NG and SG and angle between NM and SM denotes the angle of declination. That is how much deviation between the magnetic and North Pole and South Pole, or Earth magnetic axis and the Earth geographic axis. This is known as angle of declination. Okay, and if the North Pole is direct or inclined towards east, then this angle is taken as positive, and if the North Pole is inclined towards west, then the value of angle taken as negative. Okay. Now let a bar magnet is placed inside the earth. Okay. Here capital R is the radius of the earth. Capital R is the radius of the earth. The direction of the bar magnet is North Pole, directs towards the magnetic South Pole or geographic South Pole of the earth, and the South Pole of the bar magnet is placed towards the magnetic North Pole of the earth. Okay, that is, North Pole of the bar magnet is placed along the magnetic South Pole of the earth, and the South Pole of the bar magnet is placed along the earth magnetic North Pole. Okay, capital M is the magnetic dipole moment of this bar magnet. Now P be a point on the earth's surface. Angle between POSM is denoted by lambda. POSM is denoted by lambda. Here pi by 2 minus lambda is known as magnetic latitude of the point A. Magnetic latitude of the point A. Now the resultant magnetic field at the point B. Now the resultant earth magnetic field at the point B is denoted by mu0 by 4 pi capital M by R cube under root of 1 plus 3 cos square lambda. This proof I already done in my previous videos. Okay. Let capital M is the magnetic dipole moment of this bar magnet. Now P be a point at a distance r from the midpoint of this bar magnet, and lambda is the angle between OP and ON. Okay. Now we can resolve M into two mutually perpendicular components. Along r direction it is denoted by M cos lambda, and along theta direction it is denoted by M sin lambda. Now the intensity of magnetic field at the point P along the r direction is Br is equal to mu0 by 4 pi 2M cos lambda by r cube, and along theta direction, that is normal to Br, it is denoted by M cos lambda by r cube. Okay. Now the resultant magnetic field at the point P is B is equal to under root of Br square plus B theta square. Here Br is normal to B theta. Now substituting this value or putting this value in the of Br and B theta, we have B is equal to mu0 by 4 pi 2M by r cube under root of 4 cos square lambda plus sin square lambda. This is equal to mu 0 by 4 pi 2m by r cube under root of 1 plus 3 cos square lambda. This is the expression of the previous topic. You know that magnetic lines of force starts from the north pole of a bar magnet and ends at the south pole of a bar magnet. That is, magnetic lines of force starts from north pole and ends at the south pole of a bar magnet. Okay. We already considered that there is a huge magnet inside the earth surface at the center, and direction of the bar magnet is such that the north pole of the bar magnet towards the magnetic south pole of the earth, and the south pole of the bar magnet directs towards the magnetic north pole of the earth. Okay, that's why the lines of force of the bar magnet starts from the north pole and ends at the south pole. Similarly, starts at the from the north pole and ends at the south pole. And outside the earth, we can see that the earth magnetic lines of force starts from the magnetic earth south pole, or starts from the south pole of the earth and ends at the earth north pole. Okay, that's why we can see that the outside the earth, the direction of magnetic lines of force starts from the magnetic earth south pole and ends at the magnetic earth north pole. Okay, it is opposite to the magnet bar, opposite to the direction of the lines of force of the bar magnet. Okay, this is the explanation of direction of earth magnetic lines of force. Let a bar magnet is placed on the earth's surface, as north pole of the bar magnet is placed along the magnetic north pole of the earth, and south pole of the bar magnet is along the magnetic south pole of the earth. Okay, now we can find 2 points on the perpendicular bisector of the bar magnet as P and P prime, where there is no magnetic field intensity. These 2 points are known as neutral points, P and P prime. O is the center of the bar magnet. OP is equal to OP prime is equal to D. Here L2L is the effective length of the bar magnet. Capital M is the magnetic dipole moment. Capital M is the magnetic dipole moment of the bar magnet. You know that the magnetic lines of force of the bar magnet starts from the north pole and ends at the south pole, and the earth's magnetic lines of force start from the south pole and ends at the north pole. That is opposite to the bar magnet. Okay, the lines of force of the bar magnet starts from the north pole and ends at the south pole, but the earth magnetic lines of force starts from the south pole and ends the north pole. That's why we get 2 neutral points at the on the perpendicular bisector of the magnet. Let BH is the horizontal component of the earth magnetic field at a point at this place. Therefore, BH is equal to mu 0 by 4 pi capital M by D square plus L square whole to the power 3 by 2. According to this formula, we can get the position of these 2 neutral points. If we place a bar magnet such that the south pole of the bar magnet directs towards the north, and north pole of the bar magnet directs towards the south on the earth's surface, then the magnetic lines of force from the bar magnet starts from the north and ends at the south. Okay, starts from the north and ends at the south. And magnetic lines of force of the earth magnetism starts from the south and ends at the north. That is, they are acts along same direction, almost same direction. The magnetic lines of force of the bar magnet starts from north pole and ends at the south pole, and the magnetic lines of force of the earth magnetism starts from the south pole and ends at the north pole. Okay, that's why we can get two neutral points on the axis of the bar magnet at the point P and P prime. Similarly here, OP is equal to OP prime is equal to D. Similarly, BH is equal to mu 0 by 4 pi 2 md by d square minus L square whole square. From this formula, we can get the position of the 2 points P and P prime. The last two formulas we already proved in my previous video. Please watch it. You can easily understand it. Now, what is the cause of earth magnetism? Actually, in the center core of the earth, the matter likes plasma state. Matter means plasma state, and you know that there is huge amount of iron is in liquid state or plasma state. This liquid iron or plasma iron flows in a certain direction. Okay, that's why the earth magnetism is produced, and earth magnetism is very useful for us, like mobile communication, like satellite communication, and actually if there is no earth magnetism, the life does not exist on the earth, because the earth magnetic field prevents us from the harmful cosmic rays or harmful photons. Okay, the earth magnetic field plays or acts as a shield on the earth, and it protects us from the upcoming cosmic rays, harmful cosmic rays. That's why we are thankful to earth magnetism. And you know that earth magnetism changes and the direction or the poles of the earth magnetism also will be changed or changes continuously. And there are two type of changes. One is periodic changes and regular changes, and one is random changes. Okay, this periodic change can occur on observed for far time interval. Okay, but the random change, that is the random change of or the sudden change of the earth magnetic field at a place, is known as magnetic storm. Okay, that is when the magnetic field or magnetic field intensity at a place is suddenly changed due to volcanic eruption or other causes like the effect of ionosphere, etc. Then this is known as magnetic storm. And due to the magnetic storm, the mobile communication, telecommunication, radio communication, etc. will be disturbed. Okay, and now thank you for watching my video.